So I know that everyone loves to talk about security right after lunch and without a coffee break. So if you bear with me, I will try and make this as entertaining as possible while still being informative and, sticking to the things that I said I would talk about. So a little bit about me. I am at Giddins everywhere on the internet. My name is Samuel, and I am a maintainer of RubyGems bundler and RubyGems.org, and I've been contributing bugs to the aforementioned projects for about a decade. And as mentioned, I am currently the security engineer in residence at Ruby Central, so it is my full-time job to make the Ruby packaging ecosystem as secure as possible. And it's all of your jobs to make that as difficult for me as possible, I guess. So some quick goals for today. I'm going to talk a bit about the history of vulnerabilities in a very well-tested piece of infrastructure, that being RubyGems. Sort of try and scare you a bit about the big, bad, dangerous world out there. And maybe give you some nightmare fuel that you can send to your boss and say, maybe we should support this work more. I don't know. If that was too honest, I'm sorry. We'll just, give you some history and make this fun. So, what is a CVE? Before we get there, okay. Survey of RubyGems CVEs. We've got issues with Marshal, insufficient input validation, symlink traversals, ... Oh my, there's so many vulnerabilities that have cropped up in this ecosystem over the past almost 20 years. And over the past few years, there's been a slow trickle of new CVEs that the team has announced, covering both RubyGems and RubyGems.org. And we'll take a quick tour through those vulnerabilities, talk a bit about their life cycle, and see the patterns that have started to emerge, and think a bit about what we can do to make things better going forward. So, what's a CVE? Show of hands first if you've heard the 3-letter acronym CVE. That's most of you. Good. Anyone brave enough to volunteer what they think it stands for? Something with vulnerability. You are correct. Okay, so we've got another word in there. We've got common. We've got vulnerabilities. And exposures. Great. So now I'm going to quote a bit from MITRE's overly serious website about what CVEs are. What's a CVE? Well, the mission of the CVE registered mark program is to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. That was written by someone who is a marketer. There are also these things called CVE identifiers, which is an alphanumeric string that identifies a publicly disclosed vulnerability. And sort of colloquially, we security people refer to individual vulnerabilities as a CVE. What is it? It's an instance of one or more weaknesses, aka something bad, in a product, aka a piece of software, that can be exploited. So something bad can unintentionally happen, causing a negative impact to confidentiality, integrity, or availability. The negative impact is the thing that makes it bad. And a set of conditions or behaviors that allows the violation of an explicit or implicit security policy. So a vulnerability is something that breaks a promise about how that product works. So that would be promises like, we don't expose your password to other people, or, we don't let other people pretend to be you. We don't let other people upload new Rails gems if they're not supposed to. Stuff like that. So some more questions. Who here has run gem install? I see some people who didn't put their hands up, which is frankly shocking to me. I want to hear about how you're using Ruby if you've never run gem install. Similarly, have you ever put this line in a gem file? Okay, most of you. So this is sort of why you should care about this talk about security. It's because you have used the products that I work on, things like RubyGems Bundler and RubyGems.org, and any vulnerabilities in those projects, they could affect you. Talk to your doctor and see if security is right for you. To those that don't know, in America, we love putting advertisements for very expensive medications on TV, and they all sound like that. It's wild. So, another shocker, RubyGems, like any other sufficiently used piece of software, has its fair share of bugs. I didn't write them. Of course, I would never write a bug. Someone else wrote them and mysteriously placed them in the software. And being a package manager and a gem host, many of those bugs turn out to have security implications. And so now this overview is out of the way, we can dive in and talk about the first RubyGems CVE. CVE identifier CVE 2007-0469. Nice. The description of the CVE is that the extract files function in installer.rb in RubyGems before RubyGems version 0.9.1 does not check whether files exist before overwriting them, which allows user-assisted remote attackers to overwrite arbitrary files, cause a denial of service, or execute arbitrary code via crafted gem packages, aka really bad stuff. I'm curious, was anyone here using RubyGems before version 0.9.1? No old timers. Okay, that is actually surprising to me. I wasn't either. So this vulnerability was published in January of 2007, 17 and a half years ago. And it turns out that it manifested a pretty common weakness, a vulnerability of directory traversal that was fixed via improved input validation. If you've ever read patch notes for a security release of software, this sort of taxonomy should seem pretty common. Here's the weakness, the classification of it, and here's how it was fixed. And it turns out this is a pretty common one. Assumptions about untrusted input, aka random gems, can't be trusted. And we fix it by not trusting it. So in this case, we had RubyGems expecting files in a gem to all be under that gem's directory. Makes sense, you install a gem, its files belong to that gem. But that means that files in the tarball, gems are actually just gzip tarballs inside gzip tarballs. It's real fun. But RubyGems expected that all the entries in that tarball would, say, not be absolute paths, or not have ... in them to ascend the directory structure. And it didn't check that assumption when it was unpacking gems. So I could give you a gem, and if I could guess where it would be installed, I could say override literally any file on your system. Pretty bad. As I mentioned, this was from 2007. It was found and fixed. And, the description of the bug and the fix were all published in 2007. RubyGems and its associated projects have been around for a while, and a lot of the history of its vulnerabilities can be traced to the fact that they date to a more humane time on the internet. A time when we didn't talk too much about security, and we didn't assume that everything was adversarial. A time when you would download software off of forums and run it because it looked cool. It was a long time ago. The landscape has kind of changed. If we fast forward a few years, we can take a look at our worst ever CVE. Who was around for that time when RubyGems just was down for multiple days and all work stopped and you couldn't do anything? That sure was a time, wasn't it? Yeah, so what happened 11 and a half years ago is somebody pushed a gem called exploit to rubygems.org. And they were able to get arbitrary remote code execution running. They ran a bunch of code that uploaded all of the config files on rubygems.org to pastebin. This was problematic. Funny enough, this actually didn't even get its own CVE identifier. The root cause was the great YAML remote code execution vulnerability. Anyone who was deploying a Rails app back in January of 2013 probably has traumatic memories about this. Can anyone confirm? I'm seeing some nodding. And so, everyone was too busy fixing and verifying that nothing was tampered with to do something like file to get a CVE identifier assigned. And part of that involved rebuilding 100% of the RubyGems.org infrastructure, because who knew what code had been run on the server? Oops. This was also back in the day when you didn't have containers and Kubernetes and all of that good stuff. There was a VPS that had been hadn't been rebooted for a couple of years. That was the server. And so there had to be another the server built. In some ways, the world has gotten a bit better than it was back then. And almost half of that response time, and the same for all future RubyGems.org CVE responses, was spent on verifying that we couldn't find any evidence that the vulnerability was actually exploited. Notice I said we can't find any evidence. We can never be sure. One of the fun things about security vulnerabilities is sometimes they can be used to cover their own tracks. And so you sort of have to look for evidence that something happened. So how did we go about doing that? Well, the rubygems.org server uploaded all gems to an S3 bucket. If the server was compromised, the S3 bucket could have also been compromised. So we had to check the checksums of every file in S3 and make sure it didn't change. To do that, there were some trusted mirrors around the world that people were running, and we downloaded all of their gems and checksummed them and compared them to what was still sitting in the S3 bucket. We also use the checksums stored in the RubyGems.org database and in the database dumps that we make publicly available. Verified that there were no other instances matching the pattern of the vulnerability, which in this case was YAML that used some action dispatch class to execute arbitrary code when the YAML was deserialized, which happened because, of course, gem specs in .gems are YAML. The design of the system keeps me employed, that's what I'll say. So yeah, we were verifying that there was no rogue YAML. In other incidences, we've verified that no other published versions that are there are matching the pattern of malicious activity. And also we have to check our failed requests and make sure that none of them match the pattern either, but then don't get uploaded because someone wrote a bug in their exploit or something. And it turns out that I have run through this exact same playbook a dozen times since joining the security team. This playbook has been around for over a decade, and it turns out it's not specific to RubyGems.org. It's pretty common practice for any application that exists to serve content. So, diving in a bit to the most common weaknesses. And I'm going to split these into the 3 different applications in question, starting with RubyGems. So dating back to literally our first CVE, there have been vulnerabilities with directory traversal unpacking gems. Directory traversal is just a fancy word for you can write and read files you shouldn't have access to. Couple of ways that this has happened. We had bad tar entry file names, things like absolute paths or relative paths with ... in them. We had people writing symlinks to outside of the gems directory and then writing through the symlink to overwrite files. Had people putting malicious content in the name, version, or platform of a gem because those weren't validated separately. So if you had a gem named, say, /user / something, well, you start writing into that directory. As I mentioned, symlink directory traversal, I bring this up again because there was a period of like 5 years where someone would find a bug in our symlink handling. Every 6 months, report it, we'd fix it, we'd say, oh, thank God, we're done with all of these bugs, and it would repeat again. They've stopped coming, fortunately. I won't be so naive as to think that means we've actually fixed all of them. Arbitrary YAML deserialization has come up a few times. Moving on. We've had people putting terminal control characters into fields of a gem so that when you say gem list or gem search, you would get arbitrary output in your terminal. For a while, RubyGems shipped both a gem server and a documentation server, and there were cross-site scripting vulnerabilities in both of those, which led to us just not shipping them by default anymore. And then there's been a whole class of denial of service weaknesses. The one that's most in vogue right now is called REDOS. It stands for regular expression denial of service, and that's you craft a bad string and you make a regular expression match take forever on it. It's become kind of a game that security researchers, I think, are just playing for fun at this point. Similarly, someone found a way to make the client sanitize incredibly long strings take approximately forever. Someone uploaded a summary in their gem spec with 100,000 characters, and it took several minutes to print that summary when you searched for the gem. And someone also found out that our tar reader to read gem files would just blindly trust if you said, hey, here's a file with negative length. It would go back, continue reading in the tar file, it would hit the file with negative length, it would go back and continue reading in the tar file, on and on and on and on and on, forever. Bundlers also had its own fair share of distinct vulnerabilities. The most common class of those has been what's been termed source or dependency confusion. And it basically boils down to you download a gem from rubygems.org instead of from your company's gem server. Or you download a gem that is a typo of the one you are expecting to download. I mean, who here has ever run gem install riles? Nice. And a lot of this is just caused by a lack of namespacing in RubyGems. It's a problem we're trying to fix. There's also been a class of shell injection bugs where you could write a innocuous looking gem file and run bundle install, and when bundler would try and git clone your gem, it would instead run arbitrary commands. And finally, there's just been all of the upstream bugs from RubyGems are issues in bundler as well. RubyGems.org. Let's see, we've had issues with people overwriting content and poisoning the cache, relying on things like malicious hash collisions in like the name, version, and platform of a gem. People bypassing access controls, squatting on emails. Someone found a way to reset passwords without MFA. Everyone's favorite arbitrary YAML deserialization. A whole other host of DOS vulnerabilities, including, of course, multiple types of bombs. That's just a term for like self-referential unpacking of a file. The negative numbers in tar files. There's so many things. How do we handle this? You know, there's constant security concerns in Bundler. And being a package manager, that means it falls under the aegis of, I'm sorry for the buzzwords, but this pays for my work, software, supply chain, security. And this is something that, you know, governments are now caring about. See, for example, the US government putting out a paper that says C is bad. I'm not going to read through this whole big quote from the US Department of Homeland Security, but it boils down to the fact that our random Ruby gems have become, as a technical term, critical commercial software, according to the US government. How do we deal with that? Over the past couple of years, we've received 430 HackerOne reports, which is our responsible disclosure and bug bounty program. Each one of those reports takes time to triage. Some of them require a lot of testing. We fixed 64 real issues, leaving so many reports that are just useless. We've actually been working on sort of principles for what it means to run a package repository securely. And as part of that, we've actually just wrapped up a third-party audit of rubygems.org, which meant we had to scope that work and stay within a super tight budget. And now we're coordinating on how they verify that we've actually fixed the 30-something findings that they had. And then there's the security attacks that we deal with. Things like people publishing malicious gems, people typo squatting. It turns out if you prefix a gem name with active or action, people will trust it. Dependency confusion, as we mentioned, and data exfiltration. Things like trying to send all of your environment variables to pastebin. What's old is new again, it turns out. And then there's the things that are not quite attacks, but manifest as sort of vulnerabilities in the system. Things like me as the on-call waking up and asking, why is the site getting so many 500s right now? Why am I getting paged? Hey, why is there one IP address making 10,000 requests per second? Now, why is the site down? If this is you, please stop it. And it turns out, oh, it's a security researcher is hitting every gem for an endpoint on the whole system and fixed it, added a missing index, and asked them to politely stop. We're running out of time. I'm sorry. I'm going to skip over some of the stuff that I've been working on. There's a cool project called RubyGems Research. Ask me about it. And tell you that we run an official security program. As I mentioned, HackerOne, hackerone.com/RubyGems. If you find a vulnerability, report it to us there, please, not in public. We also have a private security email that goes to our entire security team, backed by a 24/7 on-call rotation. And again, please get in touch privately if you suspect there's a vulnerability in bundler, rubygems.org, or RubyGems. Give us a chance to fix it. And if you find issues with individual gems, don't report those to us. Report them to the gem's author. You'd be surprised. And every time there's a vulnerability, we go through this common life cycle. There's a report. Someone tells us and points out that there's an issue. We have to triage the report. Say, is this true? Is this important? Is this a vulnerability? If so, stop the bleeding. Like disable uploading gems or delete the bad thing that someone uploaded. Fix the source of the vulnerability, verify the fix. Very important to verify. We've really easy to think you've fixed a bug if you haven't actually tested it. We have to assess the impact, see if there were other things that happened we didn't know about, backfill the fix in old versions after we implemented it, and then finally disclose what happened, why, and what we're doing to make sure it doesn't happen again. There are also a bunch of big projects that we're working on to improve the overall situation of Ruby packaging ecosystem security. The big one's called SigStore. Won't bore you with it. I've spent a bunch of time talking about it recently. All this to say that all this work that I've been talking about costs a bunch of money, and it is supported by our generous sponsors. AWS, Fastly, Datadog, and Honeybadger, chief among them. It's also supported by donations to Ruby Central, chiefly from Shopify, the German STF, and OpenSSF's Alpha Omega. And finally, AWS. They host the service and pay for me to be here. There's also a big thing I've been working on called trusted publishing that lets you automate publishing gems from CI, making it less likely that you will be the source of a vulnerability. And if you'd like, I can help you set it up for your gems this afternoon. And all of this is made possible by contributions from users like you, your companies, and security-minded organizations like the STF, OpenSSF, AWS, Shopify, and more. I hope that you have enjoyed this whirlwind, sorry for the rush at the end, tour through uh, the history of RubyGems CVEs. Thank you, and come chat about RubyGems.